From transformational drones to complicated geometries, robotics has redesigned the wheel to an unimaginable state. Wheels are no longer only used for transporting huge goods. They power automobiles, bicycles, trains, airplanes, and other forms of mobility. The creation of the wheel marks a watershed moment in human evolution. Its simplicity and efficacy have made it a necessary component of our daily life. Wheels make life easier and more pleasurable, whether you're sprinting in a car or safely navigating your shopping cart. Welcome back to AI Mastery Collective, the place we dive into the deep world of technology. Before moving on, there is a reminder. If you have not yet subscribed to my channel, make sure you subscribe and ring the notification bell so that you don't miss out on any newly uploaded videos. Now let's move on. The M4 raised the standard for what a hybrid car was capable of. It has propeller-integrated actuation wheels. This saves energy by enabling it to move on the ground. Taken another way, compared to a standard drone, it can avoid the restricted flying duration and have a greater range. The Dragon is another truly amazing craft that possesses this transformational power. This was a multi-hinged platform that could change into another object to overcome obstructions or increase the front-end torque needed to turn valves. The release of the Delta was particularly intriguing because it combined the characteristics of the M4 and the Dragon. It can become the wheel itself with vectorable thrusters and associated modules. However, when it's in the air, it can create various objects. It could conserve energy while simultaneously moving at a moderate speed to a new spot on the ground. Like the Dragon drone, it is capable of changing from airborne to carrying out a particular function after it arrives at its destination. Although it is still a prototype, it shows the promise of multi-linked robots and may require some fine-tuning for faster servo response. The monocycle hybrid robotic platform is difficult to balance and extremely complex. What further advancements can we make to this in the future? Including actuating parts is one approach, and the Ringbot does this by integrating separate drive modules that are housed inside the body. Every module has the ability to maintain its position or even complete full rotations within the wheel. It can drive up to 3 miles per hour thanks to this, but it can also shift its weight and turn to become functional. This particular robot's concept was validated by testing its controls in a simulation environment before being deployed in the actual world. In the future, the team intends to create an even more advanced version, and it could potentially be able to be integrated into a hybrid robotic flying drone to allow robots to change into wheels. When it comes to obstacles, the OmniWeg is a little better than the others given that it can convert its smooth wheels into a wheel leg. However, each wheel has a mecanum drive, which implies that the rollers are angled at a 45-degree angle. It can use the diagonal force produced by the wheels to spin the robot in any direction by spinning them in specific patterns. To provide this method of driving, every wheel would require its own drive. Additionally, a servo is required to engage its wheel leg. The Animal is probably one of the most remarkable robotic dog models. It is based on learning by doing in a reward-driven environment. So it can learn these motion controls in a training environment, often known as a simulation, after which it knows both manipulation and movement. This can then be successfully implemented in the real robot. It obviously outperforms what a regular robotic dog can achieve. However, it uses the wheel to manipulate items, which is what separates this particular kind of robotic platform. The wheel can be gradually adjusted into various complications, yet this can be the most challenging part, because it's important to keep a nice surface for efficiency, while also wanting something capable of climbing over obstacles. So it needs to be transformative in a particular sense. The PATS wheel employs a single mono-transformable component with a pad, claw, and coupler, which is a distinct strategy. The robot can climb obstacles because it presses down on the pad when it is in tough terrain. However, the fact that this specific robot is built from a single printed element and doesn't require any additional sensors, actuators, or controllers at all is what really sets it apart. It resembles a form of metamaterial in several aspects, with the structure moving according to a predefined path. The wheel's ability to remain efficient despite its high level of responsiveness is another clever design feature. The wheelbot is an intriguing concept due to its ability to measure acceleration and rotational velocity. It can drive on the one wheel that is on the ground since it accelerates an additional response wheel, but it may additionally employ a response control event to get up from a halt. We are headed to the end of this video. Thank you for hanging on till the end. These technologies will transform our lives in an unbelievable manner in the near future. What are your thoughts about today's video? Don't forget to write your thoughts in the comments section. Let's meet again with another interesting video.